Queen Elizabeth came here, and she had the same impression as you, by visiting the sculpture, okay? Because usually a sculpture, you don't get in, you go around. I am Pierre Engel. I am civil engineer, structural engineer. I work on projects of construction for ArcelorMittal, and I also teach to architects. Construction is a very fragmented job. You have people specialized for foundation, people specialized for structure, people specialized for fluid, for air conditioning, heating system, people specialized for facade, and for engineer, a specialist for sustainability. Everybody has got his own story, his own truth. And I think Steel Agents brings that to have a global approach, a global analysis to this construction problem to be solved. The requirements we need to fulfill those days are much more complicated. Today, nobody knows really the cost of a building. You're the client, you know how much you've paid. You're the contractor, you know how much you're tender. Who knows the right price? Steel Agent is also an help to quote, to give the true price of the solution. And today, Steel Agent is at the beginning, but you can imagine Steel Agents become an expert system. And it makes you a very different approach. One of the problems we face is education of architects and engineers. When you teach 6 or 7 hours a week of traditional construction, you teach about 1.5 hours of steel construction. Imagine you have to speak which language you use. Well, you use the language you're more familiar. And of course, if you use always the same solution, you reach a situation where you become obsolete. The advantage of Steel Agents is to see the technical problem at long haul and to see the contextual economical problem at the time where you use the software. You can then reach a situation where you have the best solution at the best price. You imagine that you build in central London a small building. You imagine the congestion of the traffic. So what are you going to use? Quicker delivery, lower weight, lower volume? Or lower delivery, huge weight, huge volume? Well, the choice is obvious. You have a station, of course, at the bottom of the shard. And the conditions of construction were very, very difficult. And they rebuilt a new station by dismantling gradually the old structure. So that's a proof of flexibility of steel. We are building a new headquarters, and we have 18-meter span without column. So that's a great benefit, because when you are a developer, you also appreciate that. And architect having this software package can quickly decide and transmit that to engineers. We are not pretending that architects do the job of engineers. They are not doing it, and vice versa. But there is a continuous exchange and discussion between them, and they will have a common tool. Here is an example of what we want to achieve. Okay, we want a building. It's a workspace. It's an office building. Here you have the steel skeleton. Of course, when you see this, you don't recognize this because you just have a part of the structure. And now you see the beam, 18-meter span beam, and the floor is integrated. You have a clean and nice and neat floor. All that is in steel, and this is a proof that you can do elegant things with steels. Another thing is also, when you build with steel, you can have reduced floor thickness. When I'm saying floor thickness, it's a slab plus beam. And if you save every floor 20 centimeters, you imagine what you get after 15 stories. You get one more floor. Usually people think architects are creative. Sometimes they say they're artists. And engineers are Cartesian, they calculate. And developer, They just look at the money. Your city plan buildings can be different, depending on the space you use on the ground. And of course, this is also important because the less you occupy the ground, and the better it is on the sustainability point of view. Sustainability is something you cannot avoid today. It is requested by the specification, it is requested by the sustainability label, and the client loves sustainability label. Steel is a wonderful material because you can rehabilitate any other construction with steel. The European Court of Justice in Luxembourg, and Eero Saarinen designed that to be the Court of Justice, and 50 years later, another architect dismantled that, cleaned it up, redrilled it, and reused it. When you have to transform a building, it is easier to transform a steel building. Imagine you have a building in steel. How do you build it? It's like a meccano. You have members and bolts and nuts. So you erect it. This is what we did it with Orbit. Of course, we don't want Orbit to be dismantled, but Orbit could be displaced and rebuilt somewhere just by undoing the bolt. So you see this part, this node here, has been assembled in Bolton. We set it, and then after we started to bolt the other member. And you see what I said before over there. You have not much bolt over there. You see the difference between there and there. As a teacher, I would like my students to remember that steel is easy. That steel is easy and sexy. Why sexy? Because it's the closest structure to the line of the architect. And architects very often are really have problem between what they draw and what they get. They are always fighting on the size of member. Could you reduce that a bit? Oh no, it has to be bigger. We still, you have limit, but very, very low limit to get very fine member. And this is why I'm saying steel is sexy.